Hi, John here from Grape and Granary, and today we're going to be doing a little video on how to make a batch of beer from one of our Grape and Granary all-grain beer brewing kits. So let's start out by talking a little bit about the ingredients that you're going to find in your kit, and then we'll go into some more information about the actual process. So when you buy an ingredient kit from us, an all-grain kit, you're going to get a bag of grain. You're going to need to specify whether you would like those grains to be whole or crushed. It's important how they're crushed, so we'll get into that in a little bit, but please specify whole or crushed. If you don't have a mill yourself, you're going to want to have the grains crushed by us. You're also going to have a pack of yeast. You're going to have your hops. They're going to correspond to the particular kit. You're going to have a whirlflock tablet, which is an Irish moss tablet, some priming sugar, and finally the instruction sheet. The instruction sheet is going to walk you through all of the steps involved. So let's start out first of all by taking a look at the different pieces of equipment that you need to do this, and then we'll get into the various steps. So these are the pieces of equipment that you're going to want to have on hand before you start your all-grain batch of beer. First thing you're going to need to have is a 33-quart larger enamel or stainless steel stock pot, basically 8 gallons. When it comes to all-grain brewing, we need to be able to boil the entire batch. So we're actually collecting about 6.5 gallons of liquid during this process to make a 5-gallon batch of beer. And when you bring that 6.5 gallons to a boil, it's going to expand to almost 7.5 gallons. So you really do want to have an 8-gallon size stock pot or larger. You're also going to want to have a 5-gallon size stock pot, enamel ideally or stainless steel. This is going to contain the water we're going to use to rinse the sugar out of the grain. So 2 kettles, and ideally it'd be nice if you could fit these both on your stove and heat them at the same time. We're going to be converting our starch to sugar in this stock pot, and we're going to be using this stock pot to raise the temperature of our rinse water to rinse all the sugar out of the grain. Okay? You're also going to want to have a couple miscellaneous pitchers for measuring liquid and measuring out your water, that sort of thing, and collecting it. You're also going to want to have some mechanism for straining the grain from the liquid part of the mash and separating that sugar out. For this, I'm going to use very simply a sparge bag. This is just a bag with a nylon mesh bottom. It's called a sparge bag. And this will fit right down inside the other piece of equipment that would be ideal to have, which is a 6.5 gallon bucket with a spigot on it. And if you've already been brewing beer, chances are you're already going to have one of these. All this is a bucket with a spigot, and it's 6.5 gallons. The sparge bag fits down inside the bucket, and this is going to be used to strain the liquid part of the mash from our grain. The spigot's important because we want to be able to slow down that process of rinsing the sugar out of the grain, and that'll allow us to be more efficient. All right, the first step in the all-grain brewing process is going to be to measure out our mash water. The mash water quantity is going to be dictated by the quantity of grain that we've got. I like to use 1 1/3 quarts of water for every pound of grain, and this will be specified in your recipe. Today we're going to brew an Oktoberfest, and in this recipe we've got about 10 pounds of grain. So really, math is pretty simple. We take 10 pounds, we multiply that by 1.33 quarts of water, multiply that out, divide by 4 because there's 4 quarts in a gallon, and that will tell you how much mash water you need. In this case, we need about 3.5 gallons of mash water. So this is where the pitchers come in handy. I'm going to measure out 3.5 gallons of water. I'm going to put this right into my boiling kettle, and this is going to become my mash kettle. We'll heat that water to around 160 degrees, and then we'll take our crushed grain, add that to the mash water, and stabilize the temperature right around 152 to 154 degrees. Then I'm going to add 5 gallons of water to my 5-gallon stock pot. That's going to be my rinse water. All the water that I'm using in the all-grain brewing process, of course, has to have no chlorine. So all this water that I'm using has been run through a charcoal filter. However, you could buy bottled water which won't contain chlorine. You could add a Camden tablet if you wanted to, a crushed Camden tablet to the water. That will get the chlorine gas out. So there's multiple options to dechlorinate water, but for city water supply like I'm working with, running it through a charcoal filter does a great job. So I've got 3.5 gallons of water in this stock pot, in my 8-gallon stock pot, which is going to be my mash tun, and then eventually my boil kettle. And to this 5-gallon size stock pot, this is going to be my rinse water. I'm adding 5 gallons of water. We're going to put both of these stock pots on the stove then and start adding the heat. So one more thing I want to do before I put this on the stove, I'm going to add a teaspoon of gypsum to my mash water. That's going to ensure we have enough calcium ions in our water to get the reaction to take place between the phosphorus that's in our grain and the calcium in our water. One thing about the water supply I'm using today, we live in Akron, and Akron water is actually very good for brewing because it's not very hard, it's pretty soft. However, the calcium level of the water is a little on the low side. Ideally, we want somewhere around 50 to 100 parts per million of calcium in our water, and Akron City water generally has about 30. So by adding about a teaspoon of water, I'm going to get the calcium level up to closer to 70, 80, 90 parts per million, and that'll be just fine for what we're doing. We've got our 3.5 gallons of water in our stock pot now, our 8 gallon, and we're going to turn on the flame, and we're going to heat the temperature of the water to about 160 degrees, and then we'll turn off the heat. So I've got the flame on both stock pots now. The larger one, the 8 gallon, I've got my 3.5 gallons of mash water in that I'm heating to 160 degrees. The other stock pot is my 5 gallon stock pot. I'm heating that to about 170 degrees. That's going to be my rinse water. And as you can see, I've got a thermometer in both. We want to be able to track the temperature of both stock pots simultaneously. Okay, before we do our mash-in, pouring our grain into our mash water, we're going to need to go ahead and mill the grain. So that's what we're going to do right now. I'm going to run this grain through this mill, which is a 3-roller mill. It'll actually crush the grain twice. If we crush the grain too fine, we'll have too much flour or powder that will end up clogging up our straining system. If we crush the grain too coarsely, we won't get all the sugar out of the grain that we want. So it's important that we do it right. Okay, I want you to take a quick look and see what the grain looks like when it's been milled. I'll put some on the table here, and you can see there's not too much white powder or flour there, but the grain kernels have been split in half, exposing that white powdery starch, which we will then convert to sugar. So our entire recipe of grains, or our grain bill then, is in this bag. What we have is 3 pounds of German Munich malt, 1 3/4 pounds of German Pilsner malt, 5.5 pounds of German Vienna malt, about 1 ounce of Carafa chocolate malt to give it a little extra color, and 6 ounces of melanoidin malt, which will create melanoidins and give us the flavors we would expect to have in a good Oktoberfest. At this point, the temperature of the stock pot, or the water in the stock pot, is 160, but as we pour the grain and stir into our mash water, the temperature is going to drop, and we want it to drop somewhere around 154, 155. That's going to be just about right for an Oktoberfest. Also, the flame under the stock pot is off, and we're going to keep it off for the length of the mash period, which is generally about 60 minutes. If we tend to lose temperature of our mash and it drops out of the range, say below 152, 153, we can go ahead and add additional heat by just turning on the stove and stirring gently to raise the temperature of the mash back up closer to where we want it to be. At the same time that we're beginning the mashing process, we're still heating our rinse water to 168 to 170 degrees. The temperature of our mash seems to be right around 154 degrees. So what I'm going to do now is I'm going to cover the mash, and we're just going to let it sit, and we'll come back and check it in about 15 minutes. We've just started the mashing process, and I want to show you that we have not yet converted any starch to sugar. So what I'm going to do is put a sample of the mash, just the liquid part of the mash, no bits of grain husk, into a little dish, and I've got some tincture of iodine here, and I'm going to drop 1 drop of the tincture of iodine above the sample of the mash, and you'll see what happens when the iodine hits the sample of mash. You can see it turns immediately black, and what that tells us is we have a lot of starch in solution there, and we haven't really created any sugar. Again, this is at the very beginning of the mashing process, so I wouldn't expect that we've created any sugar yet. However, we'll do this test again in about 15 or 20 minutes, and you'll see how the results of this test changes as we begin to convert the starch into sugar. At this point then, we're just sitting and waiting. Our mash is converting the starch to sugar. Over here, we're still heating our mash water to 170 degrees. Once we get close to that temperature, we can go ahead and turn down the flame in the stock pot to just maintain the temperature around 170 degrees. This would be a good opportunity while we're doing this mashing step to go ahead and start sanitizing maybe our primary fermenter, cleaning equipment, preparing for fermentation, that sort of thing. Okay, we've been mashing now for about 15 minutes, so I'm going to go ahead and do an additional iodine test so that I can show you that we're actually making progress. So again, I'm going to take a sample of my tincture of iodine, place it above my sample of mash with no grain husks in it. You'll see that as it runs down and hits the sample, it doesn't turn immediately black, it stays red. So you can see we're making some progress in the production of converting our starch to sugar. Okay, here we are at the 1 hour mark, and we're going to do one more iodine test so that you can see that all the starch has been converted. So we'll take our drop of tincture of iodine, place it on the sample, and you can see now that we're not getting any black. The sample is staying red. And we did have to bump up the temperature of the mash twice during the 1 hour because the temperature dropped a couple degrees. It doesn't have to be perfect, but you can see now we've converted all the starch to sugar and we're ready to go to do the next step. Our next step then is going to be the mash out. This is an optional step. I like to do it myself because I think it helps stabilize the mash a little bit. It also makes it easier to extract the sugar from the grain. And all I'm going to do, turn my stove on, and while the heat is on, I'm going to stir gently, and I'm going to raise the temperature from 154 degrees up to 168 degrees. I'm actually going to stop a couple degrees below 168. So when my thermometer is reading 165, I'm going to turn the heat off. The temperature will ramp up slightly to 168, and we're just going to let it sit for about 5 minutes. That'll deactivate the enzymes and make the thick sugary stuff easier to extract from the grain bed. Okay, we're going to set up now for the sparge. I've got my bottling bucket with the spigot on it. I've got my sparge bag down inside with the false bottom. And once my grain is up to 168, it's sat for 5 minutes for the mash out. I'm going to go ahead and pour my grains, or my entire mash, into the lauter tun. Make sure the spigot's turned off. We're going to let everything settle for a couple minutes, and then we're going to turn the spigot on and start a recirculation process. By recirculating for a couple of minutes, we're going to allow all the little bits of grain husk that are in the grain be trapped by this mash bed or filter bed we'll set up, and so that the liquid that's coming out that we're going to put in our boil kettle will be nice and clear. We don't want to boil a bunch of grain husks because that could extract some tannins and create some astringency in the beer. So what we want is a fairly clear looking liquid coming out of the lauter tun, which we will then collect and put in our kettle. All right, now we're ready to transfer all of our mash from our kettle directly into our mash tun. I'm going to pour it gently. We want to get everything out of the kettle and into the lauter tun. This then will become our boil kettle once we begin the runoff. So I'm going to go ahead and drain or rinse all the extra grains out of this kettle, put this on the stove, and then we'll begin the process of collecting the liquid part of this mash. I'm going to start bringing it to a boil in this kettle. All right, now we're ready to go ahead and start doing the recirculation, or sometimes it's called vorloffing. I'm just going to open the spigot up, and we're going to let the liquid start to drain out nice and slowly out of the lauter tun. And you'll notice that the stuff coming out of there right now is very cloudy and full of lots of crud. And what we're going to want to do is collect those first runnings, and instead of collecting it and putting it in our boil kettle, we're going to collect it and pour it back over the top of the grain bed. And what that's going to do is it's going to allow the grain bed to act as a filter bed, and it will start straining out the small particulate matter that's in the runoff until it starts to come out somewhat clear. It won't be perfectly clear, and it doesn't need to be perfectly clear. What we want to do is just see some improvement in the clarity of the liquid that we're collecting. So I'm just going to take that and pour it gently back over the top of the grain bed. And we're going to do this for about 3 or 4 minutes. And in this time period, that liquid is going to begin to become more clear. As you can see, our pitcher is filling up, so we're going to take some of the liquid from the pitcher and we're going to add it to the top of the mash, and we're going to continue to recirculate this until we see a significant improvement in the clarity. One thing we don't want to do is we don't want to let the grain bed dry out here. So we're going to want to make sure we continue to pour liquid over the top of the grain bed, keep everything flowing, keep it warm, and let it run. Once we're satisfied then that the clarity has improved quite a bit, we can go ahead and start to begin to save the runoff, and then we'll go ahead and add that directly to our brew kettle and start adding some heat. Once we're happy with the clarity, we'll go ahead and start saving the runoff, and we want to aim to collect about 1 pint a minute. At that flow rate, we'll be able to be very efficient at extracting the sugar from the grains. Then we're going to begin with our sparge water, adding 1 pitcher of 170-degree rinse water at a time and allowing it to filter down through the bed and extract the sugar. Then of course we're adding that collected wort directly to our boil kettle, turning on the heat and slowly bringing that to a boil. We want to continue to add rinse water so that the grain bed doesn't dry out. Okay, so here we are at 6.5 gallons of volume. We're going to go ahead and put the full heat on. We're going to bring this to a boil, and we're going to boil for 30 minutes. At the 30-minute mark, we'll go ahead and add our bittering hops. The last, say, 15 minutes of the boil, we'll be adding our flavor hops, and the last 2 minutes, we'll be adding any aroma hops, just like any other batch of beer that you've made before from extract. The only difference being, instead of doing a 60-minute boil, we're going to do a 90-minute boil. And that's necessary for many reasons, but one biggest reason is we need to take this 6.5 gallon batch and reduce it down to approximately a 5 gallon batch. So the 90-minute boil will do that. It will also coagulate a lot of proteins that will prevent the beer from being hazy and other issues we could have if we didn't do the 90-minute boil. Okay, we've got a nice rolling boil going here, so we will boil for 30 minutes. And into the 30 minutes, we'll go ahead and add our first hop addition, which will be our bittering hop addition. We've been boiling for 30 minutes. We can see that we've reduced the volume by quite a bit. And at this point, we're going to go ahead and add our bittering hops. And we'll boil for 45 more minutes, at which point we'll add our flavor hops and our wort chiller and our Rollflock tablet. Okay, 15 minutes ago, we went ahead and put our wort chiller in and our Irish moss tablet, which is our Rollflock. And we're ready to go ahead and start the cooling process. If there were any aroma hops, we would enter that now, but this is a Oktoberfest, so there's no aroma hop addition. So we're going to go ahead and turn on the wort chiller, cool this batch down to fermentation temperature, and finish it up. Okay, let's go ahead and wrap things up here. I have finished my 90-minute boil. One thing I wanted to mention to you, if you happen to overboil, in other words, you drive off more liquid than you anticipated, then you transfer your wort to your primary fermenter and you don't have 5 gallons, that's actually a better problem to have than if you don't boil off enough volume, which would tend to throw your recipe out of alignment. So I actually boiled down to about 4 3/4 gallons, so I topped up with some water. Just make sure that the water you top up with has no chlorine and it's sanitary. So you may want to boil your water or what have you. But I did bring up my volume back up a little bit to 5 gallons, so I'm ready to go ahead. Once I've got this at fermentation temperature, I'm going to go ahead and add the yeast and start the fermentation process. Again, it's like any other batch of beer that you've done before. Also, just to let you know, what I demonstrated today using the sparge bag or the grain bag is the simplest way to start for people that haven't done all grain brewing before. If you have the time, the money, or the inclination to go to the next level, there are other methods or other pieces of equipment that are a little nicer. For example, the Polarware false bottom, which fits down into the kettle. This can be used as a great way to do an all grain batch of beer. This becomes your false bottom then, and you can mash and sparge all in the same vessel rather than have to transfer the mash to a lauter tun like I did. So this would be your mash tun and your lauter tun. There are other systems like a rolled stainless steel screening that makes an excellent false bottom. This can be used with various stock pots that have ball valves already inserted in them. Blickman is another example. They make a nice kettle with a nice false bottom. That's a great way to go. And again, your mash tun and your false and your lauter tun of the same vessel. If you have any questions, please feel free to call me. I'm always here. John at Grape and Granary. Our website's www.grapeandgranary.com. And again, always reference your instruction sheet. This is going to walk you through all the steps. But if you're not sure about something, please give us a call. Again, that's John from Grape and Granary. Thanks a lot for watching.